Okay. So on example three, the whole point here was we had a little thing about here how if you're in the neighborhood, um, a linear approximation can do a good job of approximating a curve, and so they picked a value that was very very close to pi over three. So pi over three is 1 point blah 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 blah, and they're like, let's get really close. So they want you to use to approximate um, sine of 1.05 using a linear approximation, and that would have to be really really close. As a matter of fact, we're going to find out exactly how close that is. All right, so we'll start here. It's still the typical thing where it's going to be I know that I'll write it the old version first. All right, so y minus y1 okay equals m times x minus x1. And but they're wanting you to use these the function notation here, and you can or you don't have to. I mean, everything it's going to work out the same either way. And so, but if I do, so then this would be in general. So this would be f of x. So f of x could be approximated using a line, and they're going to call it L of x, and that's cool. We'll do that. Which equals this particular value. So we'll call that f of a plus the slope, which is f prime of a. So it's all the same stuff. And then x minus that particular a value. In this case, so we're trying to approximate at 1.05. So the 1.05 will be the x's, and then the pi over 3 will be the a that we're talking about. All right. So so here's what we know. So we know that f of pi over 3 okay is the sine of pi over 3, and the sine of pi over 3 is the square root of 3 over 2. So we're going to use that. That's the sine of 60. All right. And then also, so f prime of x is cosine x. And then we're going to use f prime, or sorry, our actual a value then, f prime of a. So f prime of our a is pi over 3 is going to be the cosine of pi over 3, and that's 1/2. Okay. All right. So there we go. So then we're just going to substitute in. So our equation, our linear approximation equation is going to be, so L of x is going to equal square root of 3 over 2. Well, at that particular moment. So let's see. Can I erase just a little bit? Because that's at a particular moment. I need to go ahead and. No, that was right. Yeah, it was fine. It was fine. Because it's still the line we're talking about. All right, looks like I erased it. All right, so we'll keep going though. So it was going to be so that f of x that we're talking about here is going to be the line. This is approximately. Will be approximately the line, which is the square root of 3 over 2, plus our slope. Our slope was 1/2. And then it was x minus the particular x value that we had to begin with, which was at pi over 3. Yay. And so then we're using that so that means that f of 1.05 is about equal to square root of 3 over 2 plus 1/2 of 1.05 minus pi over 3, which is a tiny amount because they picked that for that very reason, because pi over 3 is that, and then 1.05 is just barely over that. But we'll punch this all in the calculator. All right, so that approximation is going to be, and so I need calculator. So square root of 3 over 2 okay, plus 1/2 times 1.05. That's not right. 1.05 minus pi over 3. And there we go. Okay, so man, I'll just put a lot of it. All right, so what we got here? So it is 0.86742666. I mean, that's pretty dang good. Here, I'll do the whole thing, since everything. Well, not the whole thing, but everything the calculator is showing me. 282. And maybe that last 2 is rounded, and maybe it's not. Who knows? Okay, so there we are. And so then it says the error in the approximation. Okay, so your error, and they like to call that E of x. So E of x is going to be the difference between the actual function value, and which one's on top is dependent on the concavity, but we'll talk more about that later. So the actual error is going to be the f of x, okay, and then whatever the actual function value was, minus this approximation, which was L of x. All right, and so in this particular case, the error at 1.05 is going to be sine of 1.05 of 1.05 minus this value right here, which I don't want to write down again. So I'm just going to call it L of 1.05. And then whichever one was on top, determines whether this is going to be negative or not. But if we don't want to think about it, we just put an absolute value. All right, and so this will equal approximately, because I'm rounding everything, and I can come back to the calculator, and I already had that one in here, and so then I'm just going to make the value positive regardless. So if I just want to say, I'll just do it the way I've got it. All right, so sine 1.05. Dang it. I keep doing that. 1.05. All right, and make sure we should be in radian mode, so that should be fine. Minus that previous answer. All right, might be negative, might be positive. It's negative. So it's fine, because we're about to throw in an absolute value. This is going to be 5 zeros. See, if I have 10 to the negative 6, then one of those is going to be filled up with that negative 3, and then I'll have 5 zeros. All right, so here we go. So this is approximately 0.12345, and then that 6 spot's filled up with that 3, 4. Okay, so then I can say then that my error, and this is a good way to write this, my error, which could be negative or positive, as we just saw, it makes no difference. But so the absolute value of my error is definitely less than 10 to the negative, how many zeros do you see there? 5. Okay, because because this decimal place right here is 10 to the negative 6. So I'm within 10 to the negative 5 accurate. All right. And then the error happened at that point. So, man, that is really good approximation. Really good approximation. And they did it on purpose. We're close by. We're close by.